Hi, this is a video for the R help session that took place on October 19th and which was about dealing with missing data points in R. So there was some confusion during the R help session, so I hope this video will clarify any confusion that you might have from that R help session. So first of all, I have this data set called classgrades.csv, and it's under the datasets folder in the Canvas page, so you can find it there. And you can find also this R Markdown file, which I corrected and uploaded on Canvas. So let's go ahead and import the dataset, and I call my dataset raw data. So as I said during the R help session, the str function gives like a compact overview of what your data set is. So you can use that if you want to see what your data set looks like in a very compact form. So you see it gives you the number of observations, the number of variables, and then it gives you the name of each variable right here, and then the type of data that is stored. So these are numerical values, and these are only integers. So that's a useful function that you should know, especially if you have a large data set. So now let's go on to checking for missing data points. So missing data points in R are usually denoted as NA values. So there's two ways that I want to emphasize in which you can check for missing data points. So you can check by columns or by rows. So when I say by columns or by rows, I mean you want to find the total number of NA values in each column or the total number of NA values in each row. So let's go ahead and look at the columns first. So I use this isNA of raw data. IsNA function is very important because so the output of this function is either a 1 or a 0. And then whatever you put inside the parentheses here is going to check if that value is an NA value or no. And it's going to return 1 if it is an NA value, and it's going to return a 0 if it is not an NA value. So right here, you can see I put my whole data set inside that function, which basically returns a data set with the same dimensions as raw data, but only with zeros and ones. Ones where I have an NA value and zeros where I do not have an NA value. So I get that whole data set, and then I use this function colSums, which sums column-wise. And this is why, since we have 1 for every NA value, when I sum it, the contribution of the values that are there that are not NA values will be 0, and then every NA value has a value 1, which means when I sum this column-wise, I will get the total number of NA values in each column. So if we run these commands, let's see what call-checked is, just to make it clear. So we can see we have these columns, you can see the names, and then the total number of NA values in each column. So it looks like we have 1 NA value in the take-home column for the take-home variable, and then 3 NA values for the final. So this second command basically checks for the indices where we have an NA value. So this basically, if we run it, so basically which is a function that chooses any instance whenever the expression inside the parentheses is satisfied. So basically, I'm saying check this variable, which is call check, which we can see right here. So, and for every value inside call check that's greater than 0, pick that value. That's what the which function does here. But one important thing to note is, as we can see, the which function returns the index. So basically, it returns the position of the value. So we can see that the positions of the take-home and final exam are 5 and 6. So 1, 2, 3, 4, 5, and 6. And the which function returned take-home 5 and 6. So it basically returns the indices of the columns that have an NA value. So that's basically first checking how many NA values there are in each column, and then taking the indices of the columns that have at least one NA value. So now the rows is very analogous. Again, we check, but now instead of a sum by columns, we sum by rows. So we check that for the number of total NA values that are present in each row. And then if we run that command, so we can see we have 99 observations, which means we have 99 elements for each row. And then we can see that all the NA values are in different rows. So we have a total of 4 NA values, and then all of them are in separate rows. So the row indices is exactly the same. So I use the which function, but then I check for each row, and then it gives me the number of rows where the NA values are found. So we can see it's row 8, row 21, row 39, row 61. So now I just want to provide the justification why we want to use this. So in here, it might be easy, because we have only 4 missing data points, it might be easy to just go over the raw data and check for the NA value. So this is our raw data. So it might be easy to go, oh, okay, I have an NA value here, I have one here. So in this case, it might be easy. But if we have a huge data set, which is usually the case, usually models are based on large data sets, it would be very difficult and very time-consuming to do this manually. So that's why you want to have like an automated way to check for NA values. And in this particular R Markdown, I present you the ways of how to check column-wise and row-wise. So now this last command in this section is I separate out the rows where I have the NA values. So basically, I say raw data, and then I reference that. So whenever you have a data set and you use square brackets, inside you usually put, so basically, if we have raw data, and then inside we put the row number and the column number. So that's how referencing works. So basically, we're saying look at raw data and row number and then the column number. So basically, in this case, I pass along the numbers of the rows where NA data is found, and then I leave the column number empty, which means it will take all columns. And then, fair enough, if we look at review, if we look at this, the output of that, this is what we get right here. So we have rows 8, 21, 39, and 61, which is exactly the same as the indices. So, and we can see the actual NA values. We can do the same actually for the columns. So let's write it right here. So let's call it review 2. And then we will have a very similar thing, but instead of row indices, we will leave the row empty. and then we will say give me all the rows but only the columns that contain NA. So if we run this command, we will get the following. So we said that when we look at it column-wise, the only columns that have NA values are the 5th and the 6th column, which are the columns for take-home and final. So we can see that we separate out only the those two columns. So that's how you can check for where your NA values are. Now, after you check, you want to do something to these NA values because they might affect your model, of course. So we have three options in general. The first one is to remove them from the data set. The second one is to use the mean values for those variables and just replace the missing data points with these mean values, the average. Or the third option would be to use a regression to predict the missing values. Now, the first option, removing from the data set, you should always be careful when building your model. If you have a relatively low number of missing data points, you can remove them. And let's say, for example, if you have 10,000 observations and you only have 5 observations which have a missing data point, then it's pretty safe to say you can remove those 5 observations and still build your model, your linear model. But for example, if you have 10,000 observations and you have, let's say, 1,000, so that's 10%, then that might, removing those observations entirely might affect your model and might provide you with a more inaccurate one, so one that won't be as good. So let's try, before attempting these three methods and showing how they work in R, how they're done, first let's try to build the model with the NA value still present. So we call that model 0, and let's run this. So basically, the way we do this is just the regular way that we have done it so far in the class. We use the lm command, and then we specify the function, and then the data. And then I won't spend much time on the plots and the summary now, but I will go over that at the end of this video, because I'll go over the differences between the two, differences between the options that we have to deal with NA values. So now let's show how to remove the data points completely. So basically, from our search earlier, we have the indices. So removing observations means that we remove rows, and we have the row indices already where the missing data points occur, and we can just say our new data, which is without the observations that have missing data points, is raw data, and then we reference again. So we take raw data and then we minus out the rows that contain NA values, and then we take all the columns. So basically, when we run this command, we can see that raw data, new data has 95 observations right here. So this has 95 observations compared to raw data, which has 99. So we took out 4 observations, which is exactly the number of observations that contained an NA value, at least one NA value. So now we can build the model using this new data, exactly the same way as we have done thus far. And I will compare it at the end, as I said earlier. So now let's see how we can place the average or the mean value in the missing data points. So first, we want to get the indices, both the row number and the column number for every missing data point, for every NA value. And then, as I said earlier, which gives you the indices. And now, which, when you use it with this command, it gives you the index of both the row and the column. So you want to use this command when we want the index of both the row and the column. And then again, we tested the condition that we want is .na raw data. So basically, we want the indices where the NA values occur. So this is the command that you can use. And then we can see we get four values, and we can see that we have the row numbers and the column numbers. So instead of searching row-wise and column-wise, you can, from the start, just do this command, and then you will get all the NA values. And in here, you will have the row numbers and the column numbers where these NA values occur. And we can see each row here in this data set, in this indices variable that I saved, corresponds to another NA value. So now once we know that, we want to replace it. So we want to replace each of these. So we want to replace the NA value in row 8 and column 5 and row 21 and column 6 and so on with the appropriate average. Now be careful, because we want to take the average. So we can see that in the raw data we have these 6 variables: prefix, assignment, tutorial, midterm, take home, and final. So whatever NA values are in the column for take home, let's say, we want to replace with the average values for take home, using the data points for take home, using the numbers that are given that we have for take home. So let's go ahead and start with that. So let us take, again, here we are referencing the raw data set. And so we are taking all rows, and we are taking only the indices for the columns where we have NA values. So I'm taking the value from the indices. I'm basically taking these, so the values from the second column, which corresponds to the number of columns, to the number of the columns where there's at least one NA value. So basically, let's execute this command and let's see what it gives us. So we can see that we separate out the columns from raw data which have at least one NA value. And because 6 is repeated, we can see that the sixth column is separated 3 times. So it's exactly the same column, just repeated 3 times. But this is okay, because you will see it's better to have this way, because it provides you with an automated way to just replace the missing data points without doing much more code. So now I'm gonna define this new variable average, and I'll use this function call means, which calculates, it very conveniently calculates the mean or the average value for each column in my data set. So now I take my data set, which is average column. I take this data set, and then you want to also give it this command, which basically removes the NA values from each column. Because we want to calculate if you try to calculate the mean or the average of a data set of a vector which has a missing data point inside, you will get an NA value as a result. So it won't calculate, it won't automatically ignore the missing data point. So that's why you need to give it this command here, so that when it calculates the mean of each column, it ignores the NA values. So when we run this, we can see that we get the 3 same mean values for the last 3 columns, which is what we expect because the columns were repeated, and then the average value for the first. Now we want to put these instead of the NA values that we had in raw data. So let's define a new data set which will have the missing data points replaced by the average values. Let's call it raw data 2. So now raw data 2 to start with is the same as raw data. But in raw data 2, using the indices or the positions where the NA values are, we want to make the values at those positions equal to the average values that we found here. And this is simply, this can simply be done by using this line. So now let's check what raw data is. So our original raw data, let's take a look here, has an NA value in the 8th row and in the column for take home right here. So if we take a look at raw data, we can see that that value has been replaced by the average value that we have calculated before. So the method works. Also, you can go ahead and check the others, the other NA values. Once we have this new data set, we can go ahead and build our model, just as we have done so far. So finally, we can use a regression. So now, the point here is you want to use a variable that has no missing values, and you want to use that as a predictor variable for the other variable. It can be a little confusing, but it can be useful in some instances. I won't go into the details, but I will just show you how you can do this. So basically, one way to reason is that you want to use the variable as a predictor variable whenever that variable is statistically significant. So basically, if you have a bunch of variables that do not have missing data points and that are potential candidates to use as a predictor variable to fill out the missing data points for another variable, you want to use the one that has that is the most statistically significant, which you can find by the initial by building an initial linear model. So first, I want to show you how to check for missing NA values. So you can use the methods that we used before and then check, which columns, which means which variables have missing data points, or if you have the indices of the columns which already have at least one missing data point or NA value, you can use this command. So we say we want the column names of data for those columns. That's what this command means. And then we can see that take home and final have at least one NA value. So in this particular example, we see that midterm is the most statistically significant. So we choose that as a predictor variable to fill in the missing values for take home and for final. So now we name these two new linear models, and then we want to predict take home and final from midterm. And we use the same notation that we used before, and we use the raw data. Now, let's call the new data set that will have NA values replaced in it raw data 3, and to start with, it's equal to raw data. However, now inside raw data 3, we want to replace by the predicted values. So basically, we have the indices of the variables that have at least one missing data point, and we say that now let's just take a step back and just remind ourselves what call indices is. So call indices is 5 and 6. So it's just the index of the columns, or the number of the column that contains at least one NA value. And so it basically gives us the position of the variable. So now raw data 3 is equal to the initial raw data, and we want to replace, take home, the NA values in take home by the predicted value using midterm as a predictor in this case. So now we say raw data and for all rows and for the column 5 for take home. And then we use this function with, which basically takes the raw data. It takes the raw data set, and then it checks. So that this is an if statement. So basically, if in take home we see an NA value, then we want to replace that value by the predicted value from fx. And if not, we just want to keep the original take home. So that's what this if-else statement means. And this is the way you can word it. So once we do that, and then we do exactly the same for the second for the column for final. So now let's look at our raw data 3 that we defined just to check. So basically, we can see that all the numbers are the same. Let's take a look at the take home column here. So we can see that all the other numbers are the same, but the NA value has been replaced by the predicted value here. And all the others are the same. Yes, they've just been expanded. They just have zeros added because of the calculation of the predicted value. But we have the same values. So that is how you can predict one variable from another and then replace the NA values with the predicted values. And then we can go ahead and build our linear model. So that concludes the overview of the specific ways in which you can deal with NA values in R. Now let's take a look at what the models produced. So let's look at the original model. So when you just do a linear model of the original dataset which contains NA values, we still get something, so we don't get an error. But in here we can see an additional line in the summary. So when you do the summary of the model, and we can see 4 observations deleted due to missingness. So basically R recognizes the observations where we have a missing value and it just excludes them. So this is very important to note, that if you decide to remove data points, to remove the observations, then you do not need to do anything to the dataset, like I showed earlier in the R Markdown, but you can just build your linear model. However, I want to point something out about removing data points. So you can remove observations, which means you can remove row-wise, or you can remove an entire variable if it has too many missing data points. And the usual the guideline that we were given for this class is if there's more than 10% of data missing, then you can remove the variable. So basically in our data set, just to go back, so for example, if final, in our case, final only has 3 data points missing, so the final column. But for example, from 100 observations, or 99 in our case, if there's like 20 observations missing, then you might want to consider removing that column altogether. However, it depends on your model, so you should take care that whatever you do, it makes sense for the data that you're analyzing. So let's look at the model that uses the mean values. So first of all, this is the model that is done on the dataset with removed data points. So we can see, if we just switch slides, we can see where the differences are. So we can see that the multiple R squared changed. For mean values, it actually decreased the multiple R squared. And also the adjusted R squared decreased for mean values. So in this case, mean values wouldn't be a better candidate than just removing the observations. And we can also see that the statistical significance decreased. So the p-values increased for many for many of the variables. However, we can see some difference. Here, the tutorial is more statistically significant than when using mean values compared to just using the dataset with removed data points. But none of them are per se statistically significant. So let's look at the last model using linear regression. We can see that it is very similar to just using the mean values, which makes it still a worse candidate than just removing the data points from the original dataset.